Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 9 students and the topic of discussion is number systems. In this video, we'll focus on problem solving for this particular topic. In this problem, we have to find three rational numbers between 3 and 4. Let us draw the number line first. And these are the positive numbers, and on the left of 0 are negative numbers. 3 and 4 are located here, and we have to find three rational numbers. Now the question comes, how many rational numbers are there first of all between 3 and 4? There are infinite number of rational numbers between 3 and 4. For example, 3.01, 3.02, 3.03 and so on. So we have to find some approach in finding these numbers. First number can be middle of 3 and 4. So we will take average of 3 and 4. So rational number between 3 and 4 is 3 plus 4 by 2 equal to 7 by 2. 7 by 2 is 3.5, which is the center point. So this is the first rational number. Second rational number can be found from between 3 and 7 by 2. So that will give another midpoint of 3 and 3.5, which is 7 by 2, which will give the second rational number. So rational number between 3 and 7 by 2 is 3 plus 7 by 2 by 2. We are taking average of these two numbers. Average of these two numbers. So 3 into 2, 6. 6 plus 7, 13. 13 by 2 into 2, 13 by 4. So the second rational number is 13 by 4. Now we find another rational number between 3 and 13 by 4. So rational number between 3 and 13 by 4 is average of these two numbers. 3 plus 13 by 4 by 2. 4 into 3, 12. 12 plus 13, 25. 25 by 4 into 1 by 2, which is 25 by 8. So these three are the rational numbers between 3 and 4. So we have evaluated them by finding the average of the numbers. Now in this problem we have to represent root 5 on a number line. We know root 5's value is somewhere between 2 and 3. So how do we find that exact value root 5, which is an irrational number? How do we find that? We have to write root 5 in terms of Pythagoras theorem. So we can write root 5 square equal to 2 square plus 1 square. So suppose OAB is the right angle triangle. 1 square is one side, 2 square is another side, and hypotenuse is root 5 square. So root 5 square is 5 equal to 4 plus 1, which is true. Now we move this triangle here on the number line. So these two units we are putting here as OB. OA is root 5. And this perpendicular AB is 1 unit. So this is root 5. Now we open the compass, put the center point here and draw an arc from A to C. So the point C corresponds to root 5 on the number line. That is OC is root 5. O to C is root 5. In this problem, we have to show that 0.666 and so on is a rational number. We know that if decimal digits are repeating, we can put a bar on that. So this is 0.6 bar is a rational number we have to prove. So how do we proceed? We first let x equal to 0.666 and so on. Then we multiply by 10 on both sides. Why 10? In this particular case, there is a bar over a single number only. So we will multiply by 10. Suppose this problem had another question, say like 0.67 bar. Then we would have multiplied by 100 because bar was on two decimal places. Here bar is only on one decimal place. So we are just multiplying by 10. So 10x equal to 6.666. Now we separate this number equal to this plus the remaining. So it will be 6 plus 0.666. but this number is x itself. So 10x equal to 6 plus x. Taking x on the left side, 9x equal to 6. X equal to 6 by 9, which is 2 by 3. Now what we observe that x is written in p by q form, where p and q are integers. Here p equal to 2 and q equal to 3. So this is in p by form. They are integers. So x is a rational number. That's what we wanted to prove, that this is a rational number. Now we take another example. We want to show that 0.47 bar is a rational number. Here bar is only on 7. So 7 is repeating. Again we will take the approach x equal to 0.477. The bar is on a single number, so we multiply by 10 only. 10x equal to 4.777. We want to get this 0.477. So balance will be 4.3 plus 0.477. Now we add this x 0.477, we substitute as x and take it on the left side. So 9x equal to 4.3. 4.3 is 43 by 10. When we bring 9 down, it will be x equal to 43 by 90. Again 43 and 90 are integers. So x is a rational numbers because it is written in the form p by q, where p and q are integers. Some important rules whether a number is rational or irrational. The sum or difference of a rational number and an irrational number is always irrational. What does it mean? Here 2 is a rational number, root 3 is irrational if we add that. Or if we take a rational number 4 and subtract with an irrational number root 5, the result will be a irrational number only. So 2 plus root 3 and 4 minus root 5 are irrational numbers. Similarly, the product or quotient of a non-zero rational number with an irrational number is always irrational. That is, say 3 into root 3 or 2 by root 5 or root 5 by 2 or root 3 by 3, all are irrational numbers. However, if we add, subtract, multiply or divide two irrational numbers, the result may be rational or irrational. For example, if you multiply two irrational numbers, say root 6 into root 6, both are irrational. But if we multiply, we will get answer as 6, which is a rational number. So we cannot always say that the product of two irrational numbers will be irrational. It can be rational or it can be irrational. Previously we have plotted root 5 on a number line. Root 5 is a rational number, so we plotted on a number line using the Pythagoras theorem. We put root 5 square equal to 2 square plus 1 square and we easily plotted on the number line. But the question here is root 4.2. So this cannot be easily expressed in Pythagoras form. Root 4.2 cannot be expressed in a Pythagoras form easily. So there is a proper way of doing this. So how do we proceed? First we draw the number line. Here 0, and on the left hand side of the 0 we construct 4.2 distance. So 1, 2, 3, 4, 4.2. You may argue that this is minus 4.2. No. Distance is always positive. Whether you construct on the right hand side or on the left hand side, distance moved is always positive. So this distance is 4.2. This 4, 5 and 0.2 is here. So from 0 we have marked a point 4.2. Then always on the right of 0 we mark a point on 1. That is fixed irrespective of any quotient. Suppose here it is 5.6. Then we will mark 5.6 here and again 1 on here. So between these two marked points we will first get the center of the circle. Center of circle is how much? 4.2 plus 1, 5.2 divided by 2 is 2.6. So from 2.6 if we start from here, 1, 2, 2.6. So this is the center of the circle. So we will draw a semicircle. We have drawn a semicircle. Then from the origin or from the O point, if we draw a vertical, it touches the circle at point A. touches the semicircle at point A. Then OA is root 4.2. This is by theorem. We are not going to prove this, but it can be proved. So OA is 4.2, square root 4.2. Now we will take a compass, put it at 0 and open at A point and draw an arc. It touches the number line at point B. So that point B is, or OB is square root 4.2. OB equal to square root 4.2. So I will repeat the procedure again. Whatever is there to be found out, we will find the distance on the left side of the number line, make a point there. Then on the right side, we will make a point on 1. Then find the center of the circle, draw a semicircle. Then from the origin, construct a vertical line which meets the semicircle at point A. Then take the radius OA from the compass and draw an arc. It intersects the number line at point B. OB is square root 4.2. Now we have to rationalize the denominator 1 by root 7 minus 3. What do you mean by rationalize the? We have to make this denominator as a rational number. So what we have to do? Basically we have to get rid of this square root term. So that is our aim. We have to get any other number is okay, but we have to remove square root from denominator. So how do we remove? If we multiply this by another square root, say root 7, then this number will get rid of that. So the rationalizing procedure is like this: 1 by square root minus 3, we have to multiply this by square root 7 plus 3 and square root 7 plus 3. Why? Now a minus b into a plus b will be a square minus b square. So root 7 into root 7 is 7, minus b square is minus 9, and numerator this will be left. So answer will be root 7 plus 3 by minus 2. Now we observe that from the denominator square root term has been removed. In general, how do we proceed? Suppose this was root 7 plus 3, then what we would have done? We would have multiplied by root 7 minus 3 and root 7 minus 3. In the denominator, we should bring a minus b into a plus b form. If it is a plus b here, we will multiply by a minus b. If it is a minus b here, we will multiply by a plus b. This is the procedure to rationalize the denominator. Now coming to the exponents. Exponents, we have certain rules like product rule. A power x into a power y is a power x plus y. Quotient rule is a power x divided a power y equal to a power x minus y. Power rule, a power x the whole y is axy. Power of a product rule, ab power x is a power x b power x. Power of fraction rule, a by b power x is equal to a power x by b power x. Zero exponent, a's power 0 is 1. Negative exponent, a power minus x is 1 over ax, and fractional exponent is a power x by y is equal to square root a power x. The power y is need not be square root, it can be cube root or higher order terms also, depending upon the y here. Or we can say this as the yth root of e power x. Now let us use those rules in simplifying this particular question. Here we have to simplify 11 power 1 by 2, 11 power 1 by 4. So once this go up, base is same, 11 is same. So we can write this as 1 by 2 minus 1 by 4, which is 1 by 4. So 11 power 1 by 4 is the simplification of this. Let us take another question. We have to find 32 power 2 by 5. So 32 equal to, we can write as 2 into 2 into 2 into 2, which is 2 power 5. So we replace 32 as 2 power 5 and put the remaining term as 2 by 5. Now once this goes, open the bracket. Once you open the bracket, we can write 2 into 2 by 5 into 5. So 5 will get cancelled, 2 square will remain, which is equal to 4. So 32 to power 2 by 5 is nothing but 4. Friends, with this we conclude this video. I hope you like this particular video. Please like the video and subscribe the channel so that further videos can be given to you immediately. Thank you very much, friends.